What is machine learning? Machine learning describes computer systems that are able to automatically perform tasks based on data. A machine learning system takes data as input and produces an approach or solution to a problem as output without the need for human intervention. Machine learning is closely tied to the idea of algorithms. An algorithm is a set of instructions that, when followed, performs a specific task. It is like a recipe that can be programmed into a computer to do useful tasks like performing calculations or doing spell checking. With simple algorithms, there's usually one correct answer we're looking for, and the algorithm carries out the necessary steps to find it. In data science, tasks we are interested in don't always have a simple solution. For instance, we might want to categorize customers into groups with similar buying habits, or predict whether customers will purchase a new product. Machine learning algorithms take data, detect patterns in it, and then create models from those patterns that allow us to answer these sorts of questions. This process of learning a model from data is known as model training. Once a machine learning algorithm has created a model from existing data, it can be applied to new data to do things like categorizing new observations or predicting future behaviors. Applying a model to new situations is known as model testing or prediction. Machine learning algorithms fall into three general categories: supervised learning, unsupervised learning, and reinforcement learning. In supervised learning, there is a labeled target variable provided to the algorithm, and the goal is to predict that target on new observations that are not yet labeled. For instance, a company might have information on customers and whether they purchased a new product or not, and they're interested in predicting whether new customers will purchase that same product. Supervised learning problems come in two general flavors: classification, where the target is a category like yes or no, and regression, where the target value is a number. Supervised learning is the most well-developed area in machine learning and has many applications, some of which you might encounter every day. Examples include spam detection, which helps your email filter out emails you might not want to see; stock forecasting, which helps stock traders predict which stocks might do better; voice recognition, which helps personal assistants and other programs interact with people; and image recognition, which allows us to do things like recognizing faces or recognizing objects so that we can make a self-driving car. Unsupervised learning problems involve finding useful patterns in data when there is no labeled target for the algorithm to learn from. Examples of unsupervised learning tasks include clustering, where similar observations are grouped together; anomaly detection, where unusual observations are detected; and dimensionality reduction, which involves cutting out or combining variables to reduce the size of a dataset and make it easier to work with. Common applications of unsupervised learning include customer segmentation, where similar customers are put in groups; fraud detection, which attempts to flag unusual financial activity; and behavior association, which can draw links between things that commonly occur together, such as buying both milk and cereal on the same shopping trip. Reinforcement learning describes systems that act within an environment and then use feedback from those actions to take better actions in the future. Applications of reinforcement learning include game playing, like creating AI for video games, or agents capable of defeating human players at board games like chess or Go; stock trading, where algorithms can learn from past mistakes to improve returns; and robotics, where a robot can act within an environment to learn ways of doing things more safely and efficiently. In the end, the goal of machine learning is to get computers to use data to generalize about the world, to learn from what has been observed in the past, to understand new observations, and use that understanding in useful ways, like making better choices. If you'd like to see more content like this, you can hit subscribe or check out some of my other videos. Thanks for watching.